Fun stuff in store for today. Areas of regular polygons is the title. The central question, which is more a statement than a question, is define apothegm. Everyone say that word, apothegm. Hey, who's heard that before? It does sound like a possum, huh? And regular polygon. By raising hand, does anyone know what a regular polygon is?
Like a square.
A square is an example. He's correct. Okay, a square is a regular polygon, such as, you don't have to draw this because I'm going to erase it in a sec. Here's our square. Whoa, pretend that's a square. Let's try that again. Okay, here is a rectangle, a really terribly drawn rectangle. Okay, this one is regular. A regular polygon. Man, I cannot write today. And that one is not. So what's the difference? What makes the square regular, and technically a square is a rectangle as well. What makes a square regular and the other rectangle not? All sides have to be congruent. And all angles, which in both here, both already have congruent angles. So regular polygon, make sure when you're drawing them that you're trying to get the sides to be all congruent. Okay, excellent. Since we're doing areas, let's go over some basic area formulas you've been learning like your whole math career. If I raise a hand, who can tell me? And I draw the little shapes because I want to know which formula or which shape it belongs to. Area of a rectangle. Who knows that area formula? Lucas? Length times height, and we can also call it base times height, L times W, and oftentimes you see it as base times height. Those all are the same, right? Base and height, they'll have to be 90 degrees perpendicular. Okay? How about area of a triangle? Who knows that one? Raise a hand. Zach? Base times height divided by 2. Or 1/2 base times height. That would be the same as well. Because you can take any rectangle, cut it in half, and you get 2 triangles. Which is why the formula is base times height divided by 2. Because it has a relationship to a rectangle. Here's one. It's probably been a while. Area of a trapezoid. Yeah. That's volume. Yep. Okay, let me help you out a little bit. I'm going to draw a picture, and again, I'm going to be erasing this, so you don't have to draw it. Just stay with me. Like with a rectangle, we can take a trapezoid and slice it, and what 2 shapes do we get? 2 triangles. Are they the same triangle? Are they congruent? No. So essentially, to find the area of this guy, we have to go 1/2 base times height, right? And the area of this one is also 1/2 base times height. But look at their heights. Oh, I cut this in a weird way. Anyway, let's look at their bases. Are their bases congruent? No, so there are 2 different lengths of bases. And technically, that triangle and this triangle are the same height. So the only thing that differs is the bases. So here's the formula. 1/2, and you'd be adding the triangles anyway. Base 1 plus base 2 times height. 1/2 base 1 times plus base 2 times height. And lastly, raise a hand. Who knows the area formula of a circle? There's a radius in it, that's true.
Square.
There's a squared. There's something else as well.
Wait.
Torrance, let's figure it out, everyone. You're halfway there, Torrance. You said a radius and a squared. You need one more thing there.
Oh, pi.
Pi. Yeah, radius squared. Pi r squared. 2 pi r is the what formula of a circle? Circumference. And I always got them confused too. But then one day I realized, oh, area is squared, right? When we answer area, we say inches squared, feet squared. So area formula has the square. And once I made that connection in my head, then all of a sudden I could remember which was which. Area formula has to be the squared one. 2 pi r is not squared. That's just one-dimensional. It's r to the first power, so circumference is one-dimensional. Pi r squared is two-dimensional, so area is two-dimensional. All right. So there's lots of different polygons. We can have a 3-sided polygon, which is a triangle. A 4-sided polygon is a rectangle, right? What's a 5-sided polygon called? Pentagon. And if we are, if we're drawing regular, I should try to make sure that all sides are equal. So I'm going to actually draw a square. Here's my attempt at a regular pentagon. All are supposed to be equal. What comes after a pentagon? Hexagon. Oh, getting harder for me. Okay. 6-sided. And they're supposed to be equal. Okay, what comes after 6-sided? Heptagon. I'm not going to try those ones. I can do the even ones. The odd ones are hard for me. What comes after a hexagon or a heptagon? Octagon. The stop sign is an octagon. 2, 3, 4, 5, 6, 7, 8. What comes after an octagon? Nonagon. Like I said, I can't draw the odd ones. They're too hard for me. After nonagon, decagon. Okay, we're going to start, though, with an easier one for me to draw, the hexagon. So would everyone draw a hexagon large, please? Because we're going to put some stuff inside of it. But try to make it regular. Regular means they should be, all angles should be congruent, all sides should be, and you know, there's a little bit of human error because it's really hard to draw that perfectly congruent by hand. Can you catch up? Okay. Oh. There should be 6 because it's 6-sided. We're going to circumscribe a circle. A circle. The circle's going to go around the outside, but at every point, it's actually pretty good. The more and more sides we add, hey, Taurus. The more and more sides we have, we start with the triangle, then we move to quadrilateral, then a pentagon, a hexagon, a heptagon, a decagon, I don't know, a polygon, a 29gon. The more and more sides we add, what shape does it start becoming? It starts becoming, a ball is 3-dimensional. So, a circle. So it starts getting closer and closer to a circle. As we add more sides, it starts expanding closer and closer to a circle. What? It gets microscopically close. 1,000gon is still not a circle. 1,000 sides is close, but still just a hair off. You would. You can do that for homework. Have fun. Okay, in a circle though, we usually draw 2 things. What are 2 things we put in a circle? The radius, and where does the radius extend from? The middle center point? Yeah, so let's put our center point right there. And technically, this circle hits the hexagon in 6 places. So I'm going to connect all 6 radii to each of the vertices. Triangles, yeah. And how many triangles are there? 6. There's a relationship. 6-sided polygon created 6 vertices, which when we connect the radii from the circumscribed triangle or circle, we get 6 triangles. Interesting. And guess what? Are all of these radii congruent? They are, because it's all in the same circle, right? So So all of these triangles are actually isosceles triangles. And we're not going to prove it, but all the triangles are actually congruent. Alright, so we have a few things, labels we already know. We know this point in the middle is called the center. It does kind of look like a bike, that's true. We know these red dotted lines are called radii, or radius is the singular version. But technically, the hexagon doesn't expand all the way out to the circle. There's a little bit of space. Let me get the yellow one. There's a little bit of space that it's missing. So the area of the hexagon is actually a little smaller than the area of the circle because of the space there's a gap. Okay, so if we drop a perpendicular from the center of the triangle, the center of the circle, not to the edge of the circle though, but stopping at the bottom of the triangle, because that's where the hexagon stops. Altitudes create a 90-degree angle. This altitude is called the apothem. Everyone say that word. Apothem. But the altitude does not go to the edge of the circle because there's that little bit of space. It only goes to the bottom of the triangle. Okay? An apothem is the perpendicular distance from the center to the side. Let's write that down. Apothem is the perpendicular distance from the center to the polygon side. Hey, right, please. It's not the circle side, it's the polygon side. Or I like to think of it as just the altitude of each triangle. How tall each triangle is from the center of the circle. Okay, using that knowledge, we're going to solve example 1. Example 1. The figure is a regular pentagon. Once you see that word regular, you should know that all sides and all angles are congruent. If you don't see the word regular, then you can't assume that all sides are congruent unless it's marked. The figure, which I'll draw in a sec, is a regular polygon. Oh, pentagon, not just any polygon, it's a pentagon. Pentagon with radii and apothem drawn. What is the measure of each numbered angle? What is the measure of each numbered, I'll get out of your way in just a sec, angle? Did I? I did. What am I missing? Apothem. Better? Oh, yeah. Well, I really screwed that up, didn't I? Awesome. Now better? Yeah. I'm really bad at spelling. I've always been really bad at spelling, yeah. And it's getting worse. I was telling someone this yesterday. It's getting worse because now I type everything or text everything. And so the computer automatically fixes things for me. Then once I write it myself, all of a sudden I'm like, can't remember how to spell anything. I don't have automatic spell check. I really think it has to do with how much I read growing up. So I hated reading, and I hated reading. I love numbers and music, but I hated reading. So I really think the more you read, the better the speller you'll be. Alright, so here's the figure it was talking about. It says a pentagon, a regular pentagon. So try your best, please, to draw all 5 sides congruent. My base is a little short. But pretend those are congruent. Now it also says radii drawn. Radii can only come from a circle. So all of these vertices, do your best to try and not make it an oval. It might turn into an oval. But connect them with a circle. Wow, that's a terrible circle. And from the center of the circle extends radii. If it is a pentagon, that means we should have 5 radii, because the circle intersects these vertices 5 times. Have 5 points on the circle. It also says there's an apothem drawn, and then I need to give you wow, I can barely see this. Okay, here's my apothem. Remember, apothem goes from the center, perpendicular to an edge of the original polygon, not the circle. And here are the angles. Angle 1, angle 2, and this angle right here is angle 3. Yikes, we're almost out of time. Okay. Shh. As we're in short schedule, we did a lot at the beginning of class from your homework from last time. So stay with me. This really isn't that hard. What happens is there are essentially 5 triangles, correct, inside the pentagon? And all of those 5 triangles have an interior angle that connects to the center, right? Well, these 5 angles, if I spread them out, watching my marker going around, they're all connected, so essentially, when they all connect, they make a circle. What do we know about the degrees of a circle? A circle is 360 degrees. One full rotation is 360 degrees. So since this is a regular polygon, all of these interior angles have to be congruent. So to find measure of angle 1, we take 360 divided by how many angles we had. How many angles did we have? 5. Okay? Please calculate that. What is 360 divided by 5? So measure of angle 1 is 72 degrees. Okay, you have a couple like this on your homework. I believe number 1 on your homework is just like this. But it's really not hard. Angle 2 is... oh, that's too skinny. Angle 2 is in this triangle right here, but it's not the whole interior angle. Please look this way and stop talking to your neighbor. This apothem not only is perpendicular, but it bisects that angle. What does the word bisect mean? Cut in half. So if angle 1 is 72, what's half of that? 36. So we take 72 divided by 2, 36. Okay, I'm going to just draw half of the yellow triangle, the right angle part. That's my right angle. We just got that that's 36, and we're looking for angle 3. What do we know about 3 angles in a triangle? So can't I just use 180 to help me figure out angle 3? How? Yeah, subtract the sum of 90 plus 36. Okay, calculate please. What's the measure of angle 3? I'm hearing 3 different answers. 54 degrees. Okay, number 1 is just like that. Start with angle 1. Okay, 360 divided by however many sides the shape has. Then you cut it in half for angle 2. And then you use your knowledge of triangle angle sum theorem to find the third angle. Any questions there? Okay, we are going to write a postulate and a theorem and then use that for example 2 and we're done. The postulate, which just is basic, it makes total sense. But let's just state it. A postulate is if two figures are congruent. So I have two triangles that are congruent. What could you tell me about their areas? They're going to be the same. Do we have a word for the same? Starts with a C? Congruent. If two polygons are congruent, their areas are congruent. That makes logical sense. That's our postulate. If two figures are congruent, then their areas are congruent. So that's not too bad to understand. Lastly, the theorem has a formula about area. The theorem of regular polygons, again there's that word regular. So your essential question, you should be defining what it means to be a regular polygon and what a pothom is. The area, I'm going to give area capital A, of a regular polygon is half. The product, what does product mean? Does anyone know what product means? The answer to multiplication, yep. Half the product of the apothegm, that will be little a, and the perimeter, little p. So essentially, area of any regular polygon is half of the apothegm times the perimeter. Area is half the apothegm times the perimeter. Alright, now I tried this last time, my last class, and I didn't do very well drawing a 10-sided figure, but I'm going to try. What's a 10-sided figure called? Okay. Okay, I can do it. And suppose everything's supposed to be even. The more sides you add, the more it looks like a circle. Whoops, that one's off. Definitely off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woo! That's better than I did it last time. Improvement. Little by little, I'll improve. Okay, we have the base here is 8 inches. And from the center, straight down at a 90-degree angle, what's that called? What's this called right here? Apothegm. 12.3 inches. So we can find the area, which is what we're going to do. Find the area is the question. By doing a half times the area times, or the apothegm times the perimeter. Since we know it is a regular polygon, and it has 10 sides, what is the perimeter? What? 80. 8 times 10 gave me 80. So the area is 1/2 the apothegm times 80. Can you calculate that for me? And we're done after this. What is 1/2 the apothegm times 80? This is the area. What? Comes out evenly? What's the unit for area? What's the unit for area? Square inches, inches squared. Okay? So you have all the formulas you need. Apothegm's the new vocabulary. Here's the assignment. Again, number 1 is just like example 1. Actually, numbers 1 and 2, I believe, are just like example 1. We're only doing 10 problems for homework. Okay? Please do it. Our, what do we call them? Stage tests are coming up. It'd be great if you were doing your homework so you were a little bit more prepared than not doing your homework, right?